So today we'll get started with the Docker. We'll understand what is Docker, why do we need Docker, what is what are the use cases this solves and all. Right? To understand this, first let's take a use case. I'm sharing a black screen. Let us take a simple use case. Let's say there is a company which has developed an application, right? There are some prerequisites to use this app. Like it works with Ubuntu 16, it needs a Tomcat 11 to run, and it needs a Java 18, something like this, right? These are the prerequisites to work with this app. So, like there were different clients, different users who are interested to buy this app and use this, right? Like there were, let's say, different users. Right. So, but this user one is having Windows operating system. Client two is having Linux, but he's having CentOS 7. Right. And the client, and also he has got Tomcat 9. Okay. And client 3 has got Ubuntu 16, Tomcat 11, Java 18, right? So these are the different clients we have, and each one is having their own platforms, like a different operating system and all. To just use this app, each one may not be ready to change their platform, to change their operating system, right? They may not be ready to change that. So if that is the case, like how do we provide them with the application? It's very easy for client 3, means it's very easy to provide the application for client 3, right? But how about client 1 and client 3? Client 1 and client 1, sorry. So how to provide them with the app? Is that we provide the app only for those who has got all the prerequisites? If that is the case, business doesn't work, right? Business doesn't work that way, because like we need to able to provide the product for whoever interested, right? So how to handle this client 1 and client 2? How can we provide them with the app? Any solutions for this problem statement? Actually, there are multiple solutions, so you might have heard about some of them. So anything you would like to share, like how to provide them with the app? One is through virtual machines. You might have heard about it and you might have used it. Many of you might have used it, right? Virtual machines. One method is provide them with a VM. Create a Ubuntu 16 VM, put Tomcat 11, Java 8, and share the VM with client 1 and client 2. They can run this app on this particular environment, right? So this is how you can provide them with the application. There were also, like there is another solution for this problem. The another solution is containers. So a containers also does the same. You can create a container, you can create a Ubuntu container, put Tomcat 11, Java 18 and share the container. But what is the difference? When both solves the problem, how are they different, and which solution should be opted for? Right? What is the difference? Let us try to understand this. Like in virtual machines, containers both uses the concept of virtualization. Right? Both uses the same concept of virtualization. So, but in virtual machines, virtualization is done to the hardware. Whereas in containers, virtualization is done at the OS level. So, container virtualization done to the OS level is nothing but containerization. Like in the beginning, we are coming across this term, right? Containerization. So, containerization is nothing but virtualization happening at the OS level is called containerization. And how do you containerize it? Like, how can we create this environment? Through something called Docker. Docker is a tool or a software or a program, whatever you call it. It's a tool which will provide you with a containerized environment. Means you, if you want to create containers, if you want to run containers, Docker should be installed and running. That's called Docker engine, Docker daemon, like whatever you call. Docker should be installed or running. So Docker is a tool which provides containerized environment. There were other tools as well like Rocket, OCI containers, Creo, and so on. But the most widely used one is Docker. Right? We always use Docker for containerization. So, okay, we understood that, okay, virtual machines, virtualization is done at the hardware. In containers, virtualization is done at the OS level. But what does it mean? Here, to understand this, let us go to their architectural differences. Right? We'll talk about their architecture to justify the statement virtualization happening at the hardware and at the OS level. And you have to make another note of another point here. Containerization is the next level to virtualization, next step to virtualization. It doesn't replace it. So virtualization done at the OS level is a containerization. It's the next step to virtualization, but it's not going to replace virtualization. Virtualization will be still there. So why you need virtualization when you are using containerization? How do you, like what is meant by virtualization done at the hardware, virtualization to the OS level? Let us understand this with the architectural differences.
Preethi ma'am,
Yep.
a small understanding on virtual machines is I'm not sure of what it is.
I'll explain you here.
Yeah,
Okay.
yeah.
Let me go through this diagram and still you have questions. We'll again revisit this. See here, this is the infrastructure. Let's say my laptop hardware. Okay, just the hardware. So for me to use the laptop, we'll use some operating system, right? Like let's say Windows or Mac. In my case, it's a Windows. Sorry, it's a Mac or Windows, whatever. Like Windows or Mac, some operating system so that I can work on it. I think the blue color is not legible. Okay. So yeah, I will have some operating system. On top of it, earlier we learned an example, like when we are going for Linux operating system. Mine is Mac, but I want to do some hands-on, I want to do some practice, right? So to do this hands-on or a practice, I cannot go and buy another laptop, right? So I would like to run some virtual machines, which just looks and works like a normal machine, but which runs on the top of the actual machine, right? That's where we need some software called hypervisor, like Oracle VMware, VM Workstation, and so on. Some hypervisor on top of it. This is a software. So this helps in creating a virtual machine. So if you see, this is a virtual machine, right? This is a virtual machine. So these are the virtual machines. If you see here, multiple machines like VM1, let's assume this is a virtual machine 1. This is a virtual machine 2, virtual machine 3. If you see every machine, like if you look into it, every machine will have its own operating system. Why its own operating system? See, just like just now I told you, it just works and runs like a normal machine, right? So it should have its own operating system. If you see, guest operating system is nothing but the operating system of the, like its own every machine will have its own operating system, right? So which is used to run, boot, or anything if you want. These are the machines that works. And then guest operating system is nothing but a some, let's say some Linux here, some version of Linux because I need Linux, or let's say another distribution of Linux or another distribution of Windows, whatever. So every virtual machine will have its own operating system. On top of it, you'll have the application, the binaries, libraries, and the application, right? The gaming application or whatever. Let's say the company has created some gaming app, whatever. So app one and the binaries and libraries are what this application needs. Let's say assume our address book application, it needs Tomcat Java. Those are the binaries and libraries we are talking about, right?
And this virtual machine is the server, right? I mean, bottom of the device is the server.
Yes, this is the host operating system. On top of it, you'll have some virtual machines
That
which
host operating system is in ourselves only. I mean, it's either Windows or Linux or anyone, right?
are laptop, the
Okay,
main
okay.
operating system. And they are running here, but they will consume all the resources like memory, CPU will be consumed from this host only. Like whenever we are creating these VMs, we'll allocate the resources like 16 GB here, okay, maybe 20 GB, depending on the operating system, we'll allocate the resources to them.
So this hypervisor is it's one of the software, right, ma'am, to create the virtual machine.
Correct, correct. Oracle, VirtualBox, VMware, VM Workstation, these are all examples of hypervisors. So using that, you will allocate the resources to the VMs. Suppose I have got 50 GB here. Okay, I can allocate some resources here, but I cannot allocate all 50 to these VMs, right? Because some of them is needed for the OS itself. For other processes, I need the resource as well. So I cannot allocate all the resources. Also, how many VMs you run depends on how much resources you have. Like I told you, you need some resources for the host itself. If you don't leave anything for host and allocate everything to VMs, they just crash. You can't, the entire system will get crashed, right? So you need to have enough resources to run the VMs. Also, let's say if you have allocated 20 GB here, out of this 20 GB, like 18 GB might be consumed or 15 GB will be consumed by the operating system itself. Majority of the resources are allocated to the OS itself, right? Okay, because they are huge. Operating system will be huge, heavy, right? So they run slowly. Your virtual machines will be slow, and the performance will be further degraded if you put too many VMs. Too many VMs means resource constraint, no enough CPU, no enough memory, right? They become much more slower. Performance degrades. You can't put too many. It depends on your these differences we have discussed right earlier also. Like that's why you need to, like, if something goes wrong, you need to fix this issue, fix the resources, everything. If you need to run too many VMs, you have to expand the resources of your laptop, like the actual hardware. This one, the actual infrastructure should be expanded, which is costly, right? So these are the things with the virtual machine. Here the very important point to remember is to run the VMs your hardware should support. You might have seen this. When creating the VMs, your hardware should support. Means you might have noticed that you should go to the BIOS, enable, there is something called virtualization technology. You should enable it in the BIOS. Of course, it comes by default with the virtualization technology enabled. If not, you have to enable it. Means the whole point to convey here is your hardware should support running the VMs. That's what I mean. Virtualization is happening at the hardware. And like once the virtual machine is created, it just works like a normal machine. It just runs, works like how your laptop works, the same way it works. It's just running on your laptop. Am I clear with this virtual machines? And the operating system of this guest means the operating system of the VMs could be anything irrespective of the operating system of the host because they just work or run like a separate machine. Is this much clear, everyone, about VMs? That's what we discussed. We can create a VM on our laptop for learning DevOps. But then we discussed the cons it has got, right? It's cost effective because you need to expand your resources. If you have to run multiple VMs, they slow down the performance of your actual operating system and maintenance, backup, recovery, all of that you should take care of, right? So we have discussed this and just thought of getting onto a VM on a cloud. Means it's running on someone else's data center. But that's a different point. So let's assume, okay, we need to run the VMs, okay, on our system or either on cloud also, right? Okay, we discussed VMs on cloud are better, but still Again, they are same, like you need to pay the amount for the resources you consume. Of course, you pay only for what you use, for how many hours you use. But still, it's a bit challenging. I mean, it has got its own challenges to create the VMs, right? You need to pay for the huge VMs. Their performance is slow. We need something better than the virtual machines. That's where comes containers. What are containers? Again, let's take a same example. Okay, this is my laptop, hardware of
Ma'am, Preeti ma'am,
yes.
this guest OS is a choice or option? I mean, like anything, it should be from
You
our
can
side or
choose whenever
I
you're
mean,
creating a VM, you can
mm,
choose what should be your operating system. My
mm,
laptop is Mac. I want to learn DevOps. I will create a Linux VM. So you can choose the guest operating system. Again, how to choose the guest operating system? How do you load the operating system? That's a different story. Okay, that's a different subject about creating VMs. Okay, that's where this hypervisor software will be used through which you will do all of these things. So just to understand, guest operating system is here, the operating system of the VM. It could be your choice.
okay, fine.
Okay, so coming to the containers, this is my laptop. Now I want to run containers. Means containerization tool is needed. Of course, this is a laptop. Let's say this is Mac or Windows. We need to have Docker running. Docker engine is nothing but Docker tool, Docker engine, Docker daemon, whatever you call it. It should be installed and running. Perfect. Okay, we'll do that. Then once you have installed Docker, you can create containers. Okay, you can create, you can start, you can run the containers. How many? Of course, containers also will consume the resources from the host only. So how many depends on like what are the resources available for you? If it is 50 GB, okay, how much each container consumes depends on what is inside the container accordingly. But you don't have to allocate the resources beforehand. Means like a one case of virtual machines, whenever you are creating it, you will allocate the RAM and all. But containers will consume the resources dynamically depending on what is running inside. Another major difference, if you see here, there is no guest operating system. Means containers will not have their own operating system. They will just consume the operating system of the host. Means they'll not have their own kernel. They'll use the kernel of the host. Right? So what is the use of it? What is the advantage of it? Here we learned your OS is the one which is consuming majority of the resource. Your app may be just 4 GB, but your OS itself is 12 GB. So all those resources are saved, right? So resources are stay saved. Containers utilize less resources than VMs because they don't have to have their own operating system. So obviously they work really faster. Containers are faster, lightweight, means they consume less resources. So whenever you have resource constraint, limited resources, because resources are costly. So whenever you have a resource constraint, limitation on the resources, better you go for containers. Also, they are very fast. They can be created on the fly. They can be destroyed on the fly. Unlike VMs, of course, either on your own laptop or means on your own laptop means you should think about on company's own data center. Either on company's own data center or else on cloud environments. Creating VMs is a bit time taking process is there. Even though on cloud you have to create them with all the specifications and all. Containers are lightweight, they can be created on the fly. You just imagine the dictionary meaning. Container means, what is the dictionary meaning of container? A holder, which will just hold your application and the dependencies of the app. Dependencies of the app means like whatever tools and softwares the app needs, like Tomcat, Java, right? So container is like a holder which will have the application and the dependencies. That's all. Is this much clear? So container is nothing but a holder which will hold the application and the dependencies. So just that's all. Container will have your application and nothing else, nothing more. So it's a lightweight. It can be created on the fly. They consume less resources. So these are all the advantages of containers. And containers consume less resources, right? Also, here point to notice, to run the containers, your hardware need not support. You don't have your hardware to support it, because here if you see, virtualization is happening at the OS level, right? Let me ask you a question. Let's say my operating system is Windows. Okay, I have Windows operating system. Can I run another Windows 7 or Windows 2002, whatever, and some CentOS and some Ubuntu? What are all containers I can run here? Can I run all the three like VMs? Yes or not?
Yes.
Yes.
Okay, so actually here we cannot run containers of other operating systems, because just now we discussed we can't run CentOS Ubuntu. We can run any other versions of Windows because they don't have their own kernel. They'll share the kernel of the host. So a CentOS container cannot share the kernel of Windows. Simple logic. You can put only Windows, different versions are fine. That's what is containerization happening at the OS level, right? You can't run CentOS Ubuntu containers here when your host is Windows. Host means the main operating system where Docker is installed and running. In this case, the host is Windows, Docker is installed, so I can run only Windows containers. Am I making sense? Before this, I would like to tell you one more thing. Initially, Docker is developed for Linux systems. It's natively developed for Linux. But now you have Docker for Windows 10 and above, you have Docker. Of course, you have it for Mac also. Alright? So generally we use it for Linux. You can use it for Windows also. So now let me go back to some example like, okay, this is Windows laptop. Okay, I have Docker installed here. On this Windows host where Docker is installed, you can run Windows containers. Agree with this, everyone? Any version is fine. The base should be same, that's all. Let's say Windows 20,000, whatever. Okay, some Windows I can run. Can I run Linux containers here? So if I want to run Linux containers, what I should do? I should start a Linux VM here. You know virtual machine, right? Just now we are talking about Linux VM. Put Docker here. On top of it, yes, you can run Linux containers because this becomes the host for them. This is the host for this Linux containers. Am I clear? This is how you can have your containers. So that's the reason your virtualization is still there. Containerization is a next step to it. It's a next step to virtualization. It's not replacing it. Is this much clear, all of you understood?
But still, it's I mean, my OS is running in Windows only. But I mean, previously you said whatever in OS is running in operating system. On top of only we can creating the Docker containers. I mean the same Windows only, but it is applicable for the some different versions of Windows. But how it's happening in Linux?
Linux containers are not running here. Simple, the diagram speaks a lot. You are not running, this is not allowed. Let's say blue ones are Linux containers, this is not possible.
Okay, on top of the Linux container is not possible. But here you on another on a block is Linux VM Docker. How we will created that VM on top of this OS?
How did we create here? Here we create, we are talking about it, right? This is my laptop.
Yes, I mean hypervisor is there, but here is hypervisor is not there, right?
Hypervisor will be there.
Okay.
Hypervisor will be there to create a VM. Hypervisor is not the point, because I told you last class there is a bare metal architecture also where you can put a VM without hypervisor also. That's not the point. The point here is your containers are running on some host. The host operating system should match the container operating system. You can run containers only with the operating system of the same host. Here, this Linux VM is the Docker host for these containers. For blue one, this is the Docker host. This is the Docker host, means a machine where Docker is running. For Windows containers, this is the Docker host. Understood? So for Windows containers, this is the Docker host, the red one. So both are same Windows, so you can run them. For Linux, that is the Docker host, that's where they are running. If you try to run that Linux on Windows, you cannot do it. Got it now, everyone? Am I clear with this? Yes or no will help me. Is this much clear for all of you? The differences
Yes, ma'am.
with respect to the architecture, right? These are the differences with the respect to the architecture. Now, okay, we are having Linux VM also. Means where do you run containers? Containers are like some packages, some softwares. You need a machine to run, right? That machine could be again a physical server or else a virtual machine. Means virtual machines are still there. Am I making sense? So virtual machines will not be replaced. You run your container on virtual machine. Then what is the advantages? And I can run virtual machines also. There is a lot of difference. Let's suppose we deployed our address book application. Okay, let's say there is a lot of okay, there's a lot of traffic to this application and we need to scale them. Scale the application means increase the replicas, increase the instances. Okay, I want to run 100 instances of address book application. So if you want to run 100 instances, let's say you are using VMs, you have to start 100 virtual machines. Am I correct? Right? So which is not the ideal. 100 VMs, they consume lot of resources, costly maintenance, management, even though you create on cloud. Also take time consuming. What I'll do, I will just create maybe let's say 10 VMs. On top of it, I can run 100 containers which runs address book, which is very effective solution. Isn't it? Of course, the numbers are just example. Don't think that okay, 10 VMs means 10 container, 100 containers, 10 into 10. No, it depends on what is present in your container, how much resources they consume. Depends on that how many VMs. As an example, I'm telling you, the whole point is virtual machine number is reduced drastically. On top of it, you can increase your containers, which runs the actual application. Like we are talking about here, right? The app one and the dependencies. So assume this is ad book application. Dependencies are Tomcat Java. Clear? Are we good? Understood this?
Yes, ma'am.
So these are the architectural differences. So performance wise, obviously that's very clear. They are lightweight, they consume resources. As we understood the architectural differences, let's go to the performance differences of these containers, right? So performance differences are, of course, we discuss certain of them. They consume lightweight, they are very fast, they consume less resource, they can be created. There are many other advantages of using containers, which we are going to discuss in few minutes. Okay, let me clear this and uh, um, yeah, let's first come to this use cases. So when you should go for a VM and when you should go for a container. Of course, those differences would be very clear with the hands-on once you see the containers and all, but just let me give you some understanding here. If you want to run multiple applications, means I want to run address book application, I want to run a database, I want to run some message queue service, different applications, different services, better you go and put it on virtual machines, right? Or else if you want to run multiple, that's what instances, 100 instances of address book to handle the traffic. Let's say there is some, let's say address book is some shopping application. Let's take some shopping application. During festive season, there might be huge rush in the traffic, right? You want to scale to 100. So the same address book or the shopping application should be scaled to 100. Right? In that case, yes, you can go for containers. If it's the same application, you just want to replicate, you just want to increase the instances, better you go for containers. Right? And also working with the VMs are platform independent. That's what, like if you're working with the VM, virtual machines, they are platform independent. Like you can put a different VMs there. And containers are platform dependent, right? Because see, you can run Windows containers only on Windows OS. Whereas VMs are platform independent. You can run any VM with any operating system, right? And also VMs take a lot of system resources, right? They consume a lot of resources, but that's not the case with containers. And you need to have sudo privileges to import subsystems. Like you need to have root user privileges to work with the containers. We'll talk about these things in a while. And development with a Docker, like build once, run anywhere. Like you build your containers and run anywhere. They are bothered about building the containers with the code, libraries, app data, and dependencies. The whole point here is like we have seen, right? Address book application is deployed. So developers are bothered about building it. But once it is deployed, you might have seen the application works in dev environment, but it will not work in test or other environments. Do you know the reason? What could be the reason? Even we faced this issue during our hands-on. Can you point or map that particular use case where we faced this scenario? MBN package command working on EC2 instance, but it's not working on your laptop. It's working on my laptop. What is the problem? Why is this happening? We already discussed this. We faced this issue. We troubleshooted this issue. Anyone
Dependencies
would
issues.
like to?
Dependencies issues.
Dependencies, compatibilities issue actually, compatibility, the version of Java and the version of Maven which are not compatible with the plugins configured in the POM file, right? It might be working on my machine, it might not be working for you, it might be working on EC2 instance. If you implement, I mean, if you want to leverage that to a real use case, application works on developer's machine. It may not be in testing, or else it may be failed on prod. Let's say developer is using Java 18. Tester is using Java 11, so it's not working. Okay, fine, we'll upgrade that version. Later on, now it will work. But later on, again, that particular Java version might have upgraded. By like during the software updates and all, it might have again application would fail. If this happens in the production, like in the application fails in production, you know the effect of it, right? You have to spend the sleepless nights. You have to first identify the issue, fix the issue, right? These are all the challenges. You, in the sense, developers, DevOps, everyone would be engaged. So they should first identify the issue, fix it, and then the application would be running. So how can we eliminate this problem? That's why we face this problem, and also I told you you can ignore that. I mean, if you are facing an error, try to fix it. Otherwise, that's okay because there is an option to overcome this problem through Docker containers. Docker containers are nothing but like a container where application is coming along with the dependencies. Means this is your container. Okay, this comes with your application and the dependencies like Java, Tomcat, and so on. It comes along with the dependencies. So it's coming with means developer. Okay, let me put the versions. Developer earlier used to share simply like till now, this is what we did. We got this address book and we are struggling deploying it, right? By fixing the underlying dependencies. But that's a way old traditional way. But now developers will not just share the WAR file. They will share the container to DevOps teams. So it's coming with the right versions of the software. So you may run it on your machine or my machine or EC2 or test environment or stage environment. It works seamlessly because you don't have to fix it on the underlying machine. It just packed, it's a package coming with all the dependencies it needs. Is that making sense?
Yes, ma'am.
Right? So that's how it eliminates a major challenge. This environmental issue is the major challenge until containerization came. If you remember, we discussed in the demo class also. Earlier, they used to share the address book, but now developers will share your container. So it works seamlessly. That's why even though you are not a DevOps engineer, you are a developer, you should still know this part of containerization. This is called containerization, which eliminates the environmental issues. That's why earlier ops team used to take 6 months for deployment, but now it just deploys seamlessly in minutes. So this is the major problem containers would solve. So with the containers, it revolutionized the way of development and they're bothered about running the containers, access, network and all. Right? Configure once, run anywhere. Developers are bothered about running their containers. They would check the container is working or not. And ops teams, sorry, developers will be building the containers. They are not bothered about whether it will work or not, compatibility issues. They need not work on compatibility issues, rather, they could work on their application. Whereas deployment, configure once, run anywhere. They are bothered about running the containers, access, network, and all. So DevOps teams will focus on deploying it on different multiple environments seamlessly. So build once, deploy seamlessly. That's how it revolutionized the way of development and deployment. Till now, whatever tools we have learned, like Git, Jenkins, these tools are used in non-DevOps projects also, in the traditional projects also. In different ways they were used. Right? Of course, Git is used in every project, and then Jenkins also for testing and all. But the real change and the real DevOps triggers with the Docker. That's where containerization, seamless deployments happen with it. So we will learn how to do it with the hands-on, how to containerize it, what are all the components and all. Before I proceed further, any questions from anyone? Are these differences clear now? VMs, what is a VM? What is a container? The differences, are these things clear? Any questions from anywhere, anyone? All right, so let's come here to Docker objects. So here, if you see, if the differences were clear, let's talk about Docker. Till now, we were talking about, okay, create a container, share the container, right? But how do you get that container? How do you create that container? There is something called Docker image. From the Docker image, you will create a container, right? Means container is actually the running instance of an image. Running instance of an image. Container is the running instance of the image. Right? You run the image to create a container. Image, what is an image? Image is nothing but a static file, a read-only file. Read-only, a static one. Right? It's a read-only. It's a just like a file. You run it, you get a container. Till now, you're talking about they create a container, share a container, right? Actually, container will not be shared. The image is the one which is shared, because just imagine a machine. Can you share a machine? Right? Even virtual machines also will not share the machine. There will be something called VMX or .ova file. If anyone have used this, you would be knowing it. You share this file, Once you run it, you'll get a virtual machine created. Same is the case here. You share the Docker image and then container can be created, right? And there were so many images already available, already created, existing images. So many standard services are available in the form of images. All of those are available in something called Docker Hub. Docker Hub is a registry. Registry is a storage service of the image. Storage service, storage place, which is called Docker Hub, where images are stored, right? Where all the images are stored. So this is where all the images are stored. You pull the, means this is a storage place. You can download the image from here and start the containers. For example, what kind of images are available? Something like HTTPD images are available, Nginx images are available. All the standard services are available as images. You can download and use them if you want any of those services. Or what if you want to containerize your own enterprise level application like address book, right? You can create a image. It comes from something called Docker file. So first Docker file will be created, right? It is a text file. It's a read-only file. It is, sorry, not read-only file, it's simple text file. You create a Docker file which will have the application packed up with all the dependencies. When you build it, you get an image. And you run the image, you get a container. That is the life cycle. Docker file is the basic or the fundamental one from which image will be developed and from which eventually container will be developed. So from Docker file you get an image, from image you get a container, right? And from this image will be stored in the Docker Hub. See here, see from Docker file image is created. You may start and create a container or else you can also store it on Hub from where other teams can download and start a container from. These are all the different components of Docker, like Docker file, Docker image, Docker container, Docker Hub and all. We'll talk about them, we'll go through them in detail. I'm just giving you a heads up overview of those topics. Is this much clear, everyone? Understood? Any questions? This is just an overview, okay? Um,
Yeah. So in Docker Hub, it's a registry. So there the Docker images will be saved, and it's like a common registry, right? You are saying
yes, a
like
common place
like
where,
GitHub.
yes, storage place for images.
Okay.
Okay, what are all these exactly? We'll see practically with the hands-on. See, this is the formula I'm talking about. Docker file, you build the Docker file to get an image. You run the image to get a container. Right? So you build an image, build the Docker file to get an image. You run the image to get a container. Is this much clear, everyone? And container, you can see like it's something like in the transportation world. In the transportation world, is shipping. Container means you put everything and share it, right? Same is the case. Everything we can put inside the container, like the application, the dependencies, and share it. So see, Docker file is a text file which will have Docker instructions. What are those Docker instructions and all we'll learn. You build it. So how to build it, we will learn. You get an image. You run that. You get a container, right? And what is inside the image and all we'll see. This is all hands-on part. What is inside a container? It is a package with everything required to make software run, your application run, all the expected operating systems, everything. and Docker architecture we'll discuss with the lab. Once we install and start hands-on, we'll come to this. Let's get started with the hands-on. Let us install Docker and start doing the hands-on with the Docker. You can use Docker on your laptop also. If it is Windows or Mac, there will be something called Docker Desktop. You have to install it. I'll show you that also. Let me log in into PC2 first. Okay, so you can use the same instance where you can install Docker and work with it. So let me start this instance. Okay, so now let us install Docker. You can use the same instance or a new one. Install Docker should do. The -y for confirmation.
Ma'am, on cloud you are installing, right?
Yes, on EC2 instance I'm installing. Just now we connected, right?
Yes.
Just now I took this command connected to it. So Docker is installed. Start Docker, systemctl start Docker. That should start Docker. Means you can run any Docker commands now. The first most basic command, Docker images. Docker images will list all the images present on your Docker host. What is a Docker host? In this case, what
Yeah,
is Docker host? Here, Docker host is nothing but the EC2 instance where Docker is installed and Docker is running. It's a new host. There were no images as of now, so it was not listing anything. Okay, fine. I would like to run some image like Docker run hello world. But is this hello world image is available on our system? So what happens now? What it will do is it will first search for this image locally. If it is not there on the same Docker host locally, it will pull from the Docker hub. So it will Search locally. If it is not present, it will pull from Docker Hub. Let us see that. See, it is searching locally. It's not present. So it's downloading that image from Docker Hub. And once it starts a container, it is displays a message because hello world is a sample message. So if you see here Docker images, you can see the list, right? That's a image. And it has downloaded the image and it should see the container also, right? Docker PS will list the containers, only running containers. It's not listing means it might have stopped. PS minus A will list all the containers, including stopped ones. Here you can see this as container ID and the status exited. It got stopped. Why it got stopped, we'll see, but container is created. You can see this is the image. Every container will get an alphanumeric ID assigned because we can't remember that ID. Some random name is assigned by daemon bold markiless. So what if I run it again? Docker run. We just learned, right? You run the image to create a container. This time you can't see it's pulling from hub, right? It just displayed this because that's how the container, the image works. And now see another container got created. And it is just means from the same image you can create containers, multiple number of containers. Can you see that?
First, where we'll check actually inside. First time it was downloading from host. Our EC2 server, right?
First, it will search in the EC2 instance. If it is not there, it will download from Docker Hub registry, public default registry.
Okay.
So first it is not there, so it has started. And it again has another name called Nervous Mirza Khani, something like that. If you
Ma'am, in
yes,
two Docker images, no? Two hello world, right?
one
But
is old image. This is the image.
okay,
From
but
that, two containers were created.
okay.
I'm running again. Again, random name will be assigned, but I would like to give my own name. Name C1. Okay. Now, if you see, hello from Docker, and you can see a container is created. Image is only one. From the same image, we got multiple containers. See, this time my own name is assigned C1. Understood, everyone? Got it clear? Yes? Now, okay, fine, it's downloading from hub. Where is that hub? Can we see that? Yes, of course. Go to hub.docker.com. You can create a free account here, um, like you created in the GitHub. Just create a free account, or else without account also you can use. Anyone can download it. I have an account with this username Devops trainer. So just you don't have to have an account also. You can just log in and let's say hello world. I'm searching with it. It has downloaded from here. So see, this is the hello world Docker official image, means managed, maintained by Docker, an example of minimal Docker sample image, right? So this is what is downloaded, right? You can search any images here. Official images means officially managed, maintained by Docker. You can push your own images also. We'll talk about our own images later. Similarly, I would like to search for Ubuntu. Yes, you can see here, right? Official images. So anyway, we'll come to other images later. That's a basic of Docker. Okay, fine. On Linux we did. Do you want to try it on your own laptop? Yes, you can do that as well. Hmm. Ah. So if you are on your laptop, either Mac or Windows, if you want, you can go with something called Docker Desktop. This is just why this is Docker desktop. Okay, you have the official website from where you can download this Docker desktop. See, download Docker desktop for Mac or Windows or even for Linux also you have it. So Docker desktop will have the user interface like this. Okay. So in Mac you have this. Let me show you. I have installed it on Mac. You will see something like an app install. See this one. Double click to launch it. So it will have in Mac or Windows, you can use the UI. But user interface, this is very less used. In real time, we never use the user interface. We only use the CLI, command line. Just nothing but list of images, containers, all of that you can see. If you wish, you can use CLI also. This is easy to instance, right? Let me open another tab for my Mac. I'm on Mac. Because Docker is started, I just started that. I can run images. These are all my like previously downloaded images. And everything, commands, concepts remain same, work the same way. So it's up to you whether you will do the hands-on on EC2 or in your laptop. It's up to you. Only installation differs. You can see this UI also, but like I told you, UI will never be used. User interface is never used in reality. So go with a CLI. Got it, all of you? Images, run the image, same concept. Okay, let me run hello world. This is my local Mac. Docker run hello world. See, unable to find image locally. Okay, and so you will see like this. It is because it's not available, it has downloaded. Now it's available. And of course, container might have created ps -a. New container should be shown. Hello world. Okay. The name is Jolly Almeida. So you may use it on Windows or on your EC2 instance. And this EC2 instance is Linux. You can run only Linux containers. And Mac one, also you can run Linux containers only because Mac is a Linux based. So Linux containers only you can run here. If you try to download Windows containers, it wouldn't work. Just go to your Docker Hub, search for some Windows containers, Windows images. If you try to download, it wouldn't work. This is the image name. Let me try to pull it in the first in EC2. This is EC2. Docker pull means just it will download, it will not create a container. So first let me pull it. Means it is compatible. It's just name is Windows, but it's not actually a Windows one. Let me get something from Windows operating system. Here you can choose Windows operating system and you can try out this. See, here is the pull command is available. You can also run this out. Okay. Oh, it is also working. See here. Image operating system cannot be used on this platform. Operating system not supported. Do you see that? Understood now what I'm talking about in operating system compatibility? I'm sorry. I should check on images. Docker PS also like it has down. This is earlier one, but this one it hasn't downloaded. Do you see that? You don't have that image which I just pulled just now. This one is Windows based. Got it right, all of you? It wouldn't work. It will not work on Mac also because like I told you, it is also Linux based one. But if you have installed it on Windows, you can pull it. Try it out and see the difference. Here also you cannot pull because Mac also, like I told you, it's a Linux based one. See, Windows cannot be used. Whereas install Docker desktop on Windows and try out, it would work. Am I making sense? clear? And we'll talk about starting a container and many other things, running them in different modes. If you see your container is started, but it is stopped, right? So why it is stopped, how to keep them up and running, all of these things we have to learn. Also the Docker architecture. We shall pick up from here tomorrow. But any questions till this part from anyone, you can feel free to go ahead with your queries. First, set up your Docker, do the hands-on till this part before we proceed further. Any questions?
No, ma'am.
Just give me a second. 1 second, please. Any questions? I'm back. Any questions? The theoretical part we have covered today. Majority is theoretical part because you need to understand what is Docker, the architectural differences, the performance differences, and then the hands-on a little bit we have done. We'll deep dive into other commands and the hands-on in the next class. Any more questions in this part, whichever I covered today? See, Docker itself is a topic which you need to put lot of effort to understand because like it just makes a lot of change in the way of like the traditional approach is completely changed with the Docker. So you need to put effort to understand this thoroughly, but you need to understand this thoroughly to gain confidence in the further subjects like Kubernetes and all. This is the base. In Kubernetes, we deploy Docker images. People start working with Kubernetes without knowing Docker. I know how messed up it would be. So learn Docker thoroughly so that you can also master Kubernetes easily that way. So go through the recording, go through the concepts once again. Definitely you'll be having so many questions. So revisit that. Maybe if you don't want to ask at the moment, revisit the recording, come back with the questions. Tomorrow we'll have the questionnaire first and then the topic. Anything else? Are we good for today?
Yes, ma'am.
All right then. I have also shown you using it in both your own system and on the EC2. So it's up to you. If you want, you can try out both and see the differences as well, pulling the Windows image, right? So that you have to do hands-on to get clarity. All right then, if no questions, we shall close here. Thank you all. Good day. See
Thank
you
you.
tomorrow. Bye everyone.